Hello. Today we're going to do Lesson 3. Lesson 3 should be done on the second week of classes. And then, of course, don't forget to keep up on your MyLabs Plus. Lesson 3 is about linear equations, quadratic equations, and it's also a review. So the first equation we're going to do is 2x plus 4 times the quantity of 6x minus 5 equals -7. So we always follow PEMDAS, please excuse my dear Aunt Sally, when we are simplifying. So PEMDAS, please excuse my dear Aunt Sally. When we're simplifying, we start with the parentheses. There are a couple of things that are parentheses that we don't realize. For instance, a fraction bar. You have to do what's on top of the fraction bar first, and then what's on the bottom. So there's implied parentheses for that. And there's a couple other things, but as they come up, I'll let you know. Exponents. Something that a lot of people don't realize are exponents are square roots. They are actually exponents because it's x to the 1/2, but these are also opposite operations. Multiplying and division are opposite operations, and adding and subtracting are opposite operations. So when we're solving an equation, we begin with the bottom and move on up. Sometimes you have to simplify things before you can solve them. Also, sometimes you get stuck because things that are in parentheses cannot be touched unless you do the distributive property. So you want to get that cleaned up first. So yes, you work from the bottom up, but if you have some parentheses, you want to look at those first. So first we're going to get rid of this parenthesis by distributing our 4 to both the 6x and the -5. So the 2x, we just carry that on down. So it's 2x plus 4 times 6 is 24, so that becomes 24x minus 20 equals -7. Now, from here, there's actually a lot of things we can do. So let's just follow PEMDAS and do our adding and subtracting next. But if you have another thing that you like to do and it follows the rules of math, you can do that if you're very good and already know how to solve this. So we're going to add like terms. That's these two terms. Other like terms are the minus 20 and the -7, but they're not on the same side of the equal to sign. So to get them on the same side, we do opposite operation. So we're going to add 20 to both sides. And the reason we choose adding 20 is because -20 plus 20 is 0, and that cancels. So 26x equals 13, and then we're going to divide by 26 because we're moving up this ladder, and we're going to get rid of our multiplication and division. So 26 is being multiplied by x, 2x. We do the opposite, which is to divide, and then we simplify this fraction. 13 over 26 is the same as 1/2. So our answer is 1/2, or you can say 0.5. Okay, the next problem we're going to do has fractions. So we have 3x over 5 plus x over 8 minus 2 equals 7 over 10 minus 9/20 x. So this way of writing the x out front, think about it this way, that x is over 1. So that is the same as saying minus 9x, so 9x is on the top of the fraction, over 20. So here it's written out front, but it means essentially the same thing as here. And we're going to first find a common denominator. Now, there are a lot of ways to do this. This is just a linear equation. There are a lot of ways to do it. The way I am saying to do it is, let's find a common denominator first. So, our denominators are 5, 8. Remember, this 2 can be made into a fraction. People like to forget the whole number. Do not forget the whole number. 1, 20, and 20. So we have to find a common denominator. Remember, we start with the largest denominator and we see if the other numbers evenly go into it. 5 evenly goes into 20, but 8 does not. So we can't use 20. So we're going to multiply 20 by 2 and get 40. 5 goes into 40, 8 goes into 40, 1 goes into 40, and of course 20 goes into 40. So we're going to write all of these fractions with a common denominator. So just like before, when we did this with just fractions, we set it up with all of our denominators, and if we have x's on any of the fractions, we want to put those too. So we don't forget them. Okay, so now we're going to figure out how did we get from 5 to 40. We multiplied it by 8. So we have to do 3 times 8. This 3 has to be multiplied by 8. I'm just going to write it here for now. 3 times 8 times x. 8 times 5 gave us 40, so we have to multiply 5 times the x. 1 times 40 gave us 40, so we have to multiply the 2 times 40. 20 times 2 gave us 40, so we have to do 2 times the 7. And also again 20 times 2, so we have to do the 9x times 2. This is why I found a common denominator. If I multiply every single term by the same number in an equation, then I have not changed the equation. It's an equivalent equation. So I'm going to multiply everything on this side by 40. So I'm going to put the 40 here, but what I'm doing is I'm distributing the 40 to every term. And now I'm going to do the same on this side. I'm going to distribute the 40 to every term. What that does is it cancels 40 times this first one. Well, think of 40 over 40, that's 1, so the 40 cancels. 40 times the second one, the 40 cancels. 40 times this one, 40 is on the top now, and on the bottom the 40 cancels. So this 40, multiplying it through, canceled all of your denominators. And the same happens on this side. 40 times the first fraction gives us 40 over 40 as part of the fraction, which is just 1. And again here. So by finding a common denominator first, what I've done is allowed myself to just cancel out the denominator. Now from here on out, I probably will not show this step. I just wanted you to know what's going on. Just know that if you find a common denominator, then you can cancel the denominator. So that leaves just the numerator. 24, 3 times 8 is 24, so we have 24x plus 5x minus 80 equals 14 minus 18x. So I have gotten rid of all of my fractions, and now moving on up on the PEMDAS backwards, I add and subtract my like terms. These like terms are on the same side of the equal sign, so I can just add them, do what the operation it says to do. I'm going to take a couple steps to do this. If you need to take a couple steps, fine. But when we actually get into the course, I'll probably do it much faster. So now we have like terms on opposite sides of the equal to sign. So we have to do opposite operation. The 14 and the negative 80 are like terms. Likewise, the 29x and the negative 18x are like terms. But we have to decide which ones we want on which side. So if we want the x's over here, we have to add 18x. If we want the x's on the right side, we have to subtract 29x. So I always just say, well, let's put our x terms on the left, but that's not necessary. It's just a lot of people like to do it that way, so I just have gotten in the habit of doing it that way. So we'll do that. We'll add 18x to both sides. I'm going to do in the same step, since I've decided my x terms are going on the left, I'm going to put this number 80, it's negative, so I'm going to add it at the same time. I'll add it to both sides. So notice both sides of the equal to sign have a plus 18x and a plus 80. So again, if we do it to both sides, we're not actually changing our equation. It looks different, but it represents the same line. So over here we have 47x, and then that would be canceled. And then we have 94, and this would be canceled. And so now we have 47x equals 94. So we divide to get rid of what is multiplied, opposite operation. And x equals 2. There we go. Now let's do another one with fractions, but they're written a different way. So this one is like when I was saying that the fraction bar insinuates you do the top first and then you do the bottom. So this 7x minus 5 has to be done first in penthos. But we can't do 7x minus 5 first because we have unlike terms. One way, though, to think of divided by 3 technically is 1/3 times 7x minus 5. Now, again, this is not something I'm going to do every time. I just want you to see why we do this. So this is another distributive property. So we can distribute this 3. So 1/3 times 7x is the same as just saying 7x over 3. So that's all I would expect you to do, not this sidebar thing here. I just want to explain it. So we're doing 7x over 3 minus 5 over 3. So this is still the distributive property. And then we have plus 1/3 equals 1. So we're going to combine like terms first, and as like terms, we on the same side of the equal to sign, we have these two like terms, and they already have a common denominator. So I'm not going to go through and get rid of the fractions yet. I could, and all I would really have to do is change this 1 to 3 over 3. But since I have like terms that needed to be added at this point, I think I'll go ahead and combine them. So this is negative 4/3. And I can see that I'm going to add that 4/3 to both sides next. So I will go ahead and change 1 to 3 over 3. And now I'm going to do what comes next, which is to get rid of your adding and subtracting once again, because I still have two like terms that I can add and subtract. But yeah, they're on the wrong sides of the equal to sign. So I have to do the opposite operation when adding and subtracting. So I'm going to take this over here because I'm running out of room. So I have 7x over 3 equals 7 over 3 and now to get rid of the fraction 7 over 3, we can multiply by the reciprocal, which is 3 over 7. Now you could have done this in 2 steps. Opposite operation: first divide by 7, which would have canceled the 7, and then multiply by 3, which would have canceled the 3. But instead we're just going to do it in one step, which is we multiply by the reciprocal. So on this side, these turn out to be 1, so it's 1x, or just x. On this side, they also turn out to be 1. So it equals 1. X equals 1, and we're done. Now we are going to look at quadratics. Now some of this, I will say, it's hard to know sometimes what to review first because things are so related that you learn. So some of this actually I already have gone over, but I'll go over it again. So I'm reminding you of something I reminded you of last class. X squared equals 36 has 2 solutions. X can be 6 and x can be negative 6. So remember that whenever, that's that idea, whenever you're doing opposite operation, a square root as an opposite operation, you got to remember your answer could be positive or negative. Okay, so x squared equals 108. X is being squared. We do the opposite, which is square root. And once again, remember my answer can be positive or negative. And we write that with a plus or minus sign. It makes this side x. And then we have to break down the square root of 108. So let's do that.
Over here on the side, remembering how we simplify radicals, I'm just going to, since I see it's an even number, I'm going to say, well, I know 2 goes into it. Cut that number in half. 2 times 54. 2 is prime. Then 54 is also an even number, so it's divisible by 2. So that is 27. And then to get to 27, I know I can do 9 times 3. 3 is prime. And then 9 is 3 times 3. And those are also prime. So I have broken down 108 into 2 times 2 times 3 times 3 times 3. For every 2 that are alike, I could bring 1 to the outside of the radical sign. So I'll bring out a 2. There's also 2 3's. So I'll bring out a 3. And what's left underneath there is a 3. So that has to stay underneath. And that is 6 radical 3.
And that, of course, is plus or minus. So it can be a positive 6 radical 3 or a negative 6 radical 3. Next, we're going to add a little bit more to this concept. We got 5x squared minus 2x equals 78. So yes, x is squared, but at first, since there's only one x term, at first we can treat this like it is a x term, and then in the end we'll switch it up to being x squared. So we're going to add 2 to both sides, just like we were if it were just 5x minus 2 equals 78. And that gives us 5x squared equals 80. So now we have, being done to x, we have 5 being multiplied to x, so we're going to divide it. $1.16. And that means the square, we take the square root of both sides, and we remember that our answer now, because we're using square root as an opposite operation, our answer is positive or negative. And so x equals positive or negative 4. And that's our solution for x. Okay, so notice both of these, there was an x squared term. One x squared term. If there were two x squared terms, we could have combined them. But I want to look at a different type of problem. We're not going to finish this problem today. We're actually going to pick this up in a couple of days. But we would have to distribute first our 3x. And let's see what that gives us. 5 minus 6x squared. We're okay there because we've done that before. And then negative 3x times negative 4 minus 4 is a positive 12x. And that equals negative 1. Now, at negative 6x squared and 12x are not like terms. Which means we cannot combine them. And so we're going to end up not being able to solve this, and we will eventually be able to solve this problem. We'll do this when we do quadratics. But right now, just remember that we can't right now until we do quadratics and look at some strategies for solving them. However, technically, these other ones we've done are quadratics, and this last one we're going to do is also a quadratic. We can solve it at this point because we're not going to have two terms that are not like, that can't be combined. I mean, two variable terms. So if we did FOIL here, we'd have an x squared, and then when we did x times negative 2x, we'd have an x term. We'd have unlike terms. So we're actually not going to FOIL this. It makes the problem more complicated. However, at this stage, the only way to solve it is if the solution over here is 0. So if this were a 5, couldn't do it. If it were a 10, couldn't do it. Now later we'll learn how to do it, but for right now, it has to be 0. So what we're going to invoke here is what's called the zero product rule. What it says, product means to multiply. What it says, when you multiply two numbers together, if you need them to be 0, then one of these numbers has to be 0. That's the only way to get 0. If this is 10 and this is 2, it doesn't give you 0. Even if this is 10 and this is negative 10, does not give you 0. If this is 10 and this is 0, it gives you 0. If this is 0 and this is a million, it gives you 0. So if one of these is 0, or both of them, then you get 0. So that means if x plus 4, if that part of this equation were equal to 0, well then we'd be distributing a 0 and the whole thing would equal 0. Or Or if x minus 2 were to equal 0, same idea. The whole thing would equal 0. So then we think, what would x have to be for x minus 4 to equal 0? Well, let's solve this and see. Well, x would have to be negative 4. So if x were negative 4, the whole thing would be 0. And over here, if x were 2, the whole thing would be 0. So x could either be negative 4 or it could be 2. So I do want to actually show you that this is true. Let's replace x with negative 4. And then over here, let's replace it with negative 4. So negative 4 plus negative 4 is 0. And then negative 4 minus 2 is negative 6. And of course, that is true that that does equal 0. Now let's replace x with 2. So we have 2, excuse me, 2 plus 4, and that's 6. And then we have 2 minus 2, and that's 0. And yes, 6 times 0 is 0. So that's the zero product rule. If we could get a situation like this, we just set each side equal to 0. So that is all of today's lesson. You should be on the second week of classes. If you're ahead of that, that's awesome. Make sure you do your MyLabs Plus.